Good morning, students. Today we'll continue with our Unit 2, that is soil-water plant relationship and water requirement of crops. So the fourth topic of Unit 2 is evapotranspiration, common area, duty, delta, and base period. So this is lecture number 8. So what is evapotranspiration? So we should know what is evapotranspiration before proceeding with this topic. So evapotranspiration, abbreviated as ET. It is a term which is used to describe the sum of evaporation and transpiration from the Earth's land surface to the atmosphere. So evaporation, it accounts for the movement of water to the air from sources such as the soil, canopy interception, and water bodies. Transpiration accounts for the movement of water within a plant and the subsequent loss of water as vapor through stomata in its leaves. Evapotranspiration, it is an important part of the water cycle. So next is consumptive use of evapotranspiration. So what do you mean by consumptive use? So it is the sum of water need of crop and volume of transpiration in a specific time. So consumptive use is also described as amount of water needed to meet the water loss through evapotranspiration. So it generally applies to a crop, but it can be extended to a field, farm, project, or even a valley. Consumptive use is generally measured as volume per unit area, or simply as the depth of water on the irrigated area. The knowledge of consumptive use helps us to determine irrigation requirement at the farm, which should obviously be the difference between the consumptive use and the effective precipitation. So evapotranspiration is dependent on certain conditions, or rather certain factors. So there are 8 conditions or 8 factors which I have cited here. First one is temperature, second is daylight hour, third is humidity, fourth is wind movement, 5 is type of crop, 6 is stage of growth of crop, 7 is soil moisture depletion, 8 is physical and chemical properties of soil. For example, we can see in a sunny and hot climate, crops definitely needs more water per day in a cloudy and cool climate. Similarly, crops like rice or sugarcane needs more water than crops like beans and wheat. Also, fully grown crops need more water than crops which have just been planted. Next is the factors which affects the consumptive use. So consumptive use is abbreviated as capital C and capital U, CU. So here I have cited 10 points, okay? The first point is evaporation, which is dependent on humidity. Second is mean monthly temperature. Third is monthly precipitation. Fourth is wind velocity in the locality, which affects evapotranspiration. Fifth is soil type and its topography. Sixth is cropping pattern, growth stage, and type of crop. 7. Growing season of the crop. 8. Method of applying irrigation. 9. Irrigation water depth. And 10 is daylight hours. You can note down these factors for your exam purpose. Maybe I can give short notes. Maybe like you have to explain me these points in a short note way. So you note down these points, and it is very important for the exam point of view. So here is the diagram I have shown. Just like for the first column, first block, you can see crop evapotranspiration, evaporation for climate control, etc. Then in the second box, vertically you can see phreatophyte evapotranspiration, sprinkler evapotranspiration, reservoir evapotranspiration, etc. So these terms or these sectors comes under the use of consumptive use. Now you can see the next block, which is deep percolation of soil removal, excess deep percolation, excess runoff, spill, etc. And these factors comes under non-consumptive use. So the upper 2 blocks horizontally represents the beneficial uses, and the lower 2 blocks horizontally represents the non-beneficial uses. This diagram or this figure may be important for examination purpose. Here I have shown you a figure of evapotranspiration, how transpiration occurs from leaves and also from evaporation from the soil, which ultimately goes through humidity and temperature, and it finally rises up and forms the evapotranspiration. Next is common area. So what is a common area? Okay, so common area is the area which is situated around the dam or around a project where the area gets benefits from the dam. What benefits will it get? Such as irrigation, water, electricity, etc. This is an area which can be irrigated from a scheme and it is fit for cultivation. In other words, it is the area around the dam which is under its command as an irrigation source. So here I have shown a dam with a common area. So you can see the figure, I have circled it up. You can see it. The next term that we will go through is duty. So what is duty? The definition of duty is, it is an area of a particular crop irrigated by 1 cubic discharge as measured at the outlet flowing continuously during the base period expressed as hectare per cubic. So basically there are three types of duties. The first is flow duty. So what is a flow duty? It is based on the area irrigated by 1 cubic flow during entire base period in units of hectare per cubic. So this flow duty is further classified into 4 more subdivisions. First one is the fill duty. It's based on the discharge measured at the outlet and is specified for each crop. Second is average duty, which is based on the discharge measured at the head of the major distributary, hence it includes transit losses. I want you to go through the term transit losses. What does transit losses mean? The average duty is less than the fill duty. It is specified for each crop. Next is seasonal duty. It is the average duty specified for all the crops grown in the crop season. This is useful for reservoir planning of medium and minor tanks. Next is gross duty. It is based on the discharge released at the source of the entire year for all the crops grown in the common area. So here I have shown you a figure of a duty in irrigation engineering. The second type of duty is the tank duty. So it is the area irrigated by 1 million cubic meter of gross storage in a tank per year for all the crops grown in the commanded area. Third point is the well duty. It is the area irrigated by 1 well per year for all the crops grown using well irrigation. Well irrigation will study in the upcoming units. So the duty values of certain major crops I have cited it below. First is annual crops, which include sugarcane and orchards, which is 540 hectare per cubic. Second is kharif rice, 540 hectare per cubic. Kharif crops. There is a difference between kharif rice and kharif crops, which I have already mentioned in the last class. So kharif crop is 1080 hectare per cubic. Rabi crops is 1620 hectare per cubic, and HW crops, that means hot weather crops, 2000 hectare per cubic. These values are important for solving numerical problems in the upcoming classes. So you can note this down. I hope you have noted down the duty values for the major crops. Next term is base period. So what is the base period? It is the period in days from first watering before sowing seeds called germination irrigation to the last watering before harvest. This period depends upon the type of crop, soil and season. This base period is basically used for the computation of duty values. So it is denoted as B and expressed in the number of days. So here I have shown you a table of the crops and the base in days. So the crop rice, its base period is 120 days. Wheat 120 days, maize 100 days, cotton 200 days and sugarcane 320 days. Next term is delta. It is the depth of water provided during the base period for full growth of crop. If water is not allowed to evaporate, sip, or get lost from the farm in any other manner. It is expressed in centimeter for each crop in each season, and commonly used symbol is a Greek letter which is known as capital delta. Relationship between duty, or rather field duty, and delta can be established as follows. The volume calculated from duty is shown below. For 1 cubic flowing for base period B days is equal to 24 into 60 into 60. So 24 is 24 hours, 60 minutes and 60 seconds into B being the base period is meter cube. So when you multiply it, you'll get 86,400 B to irrigate D hectares of crop in a season. Here the term capital D means duty. Next, volume calculated from delta. To irrigate duty hectare of crop in the season having delta centimeter requirement, the volume required is shown here. D into 10 to the power 4, delta into 10 to the power minus 2, which is equal to 100 delta into V stands for volume meter cube. Duty, V stands for volume meter cube. So equating the volumes, when you equate these volumes, that is 100 D delta is equal to 86,400 B, you get D hectare is equal to 864 B days by delta. So this D, that is duty, is expressed in the form of hectare, base period is expressed in the form of days, and delta is expressed in the form, the unit is centimeter. Okay, so we'll continue with the relationship between duty, delta, and base period in our next class. What I want you to do is you take down this assignment for lecture 8, which is write down the methods of improving the duty. When you write down the methods, point-wise you write it down, and also you describe the points in 2-3 lines. It's not that you only give the point and you end it there, okay? So I want you to write the points and describe it in 2-3 lines. One minimum 5 to 6 points maybe. Okay, so the last date of submission is on or before 5th September, which is Saturday. And if anyone have any issues regarding mail, or if they have sent me mails and it has shown fail, it's your duty to inform me before 5th, before the date of submission, not after the date of submission. I hope I have made myself clear. If you have any doubts, any queries, you just feel free to contact me, okay? So thank you. Now we'll go through a video which helps you, or which will help you to understand more about the concepts of duty, delta, or rather irrigation, or water requirement of crops. Okay, thank you.
Evapotranspiration sounds kind of complicated, but it's actually really simple. It's basically just all the water that's lost from the surface of the land. And this loss happens through two processes. One, evaporation, and two, transpiration. Hence, evapotranspiration. Anyway, let's look at the evaporative part. Evaporation happens when solar radiation from the sun heats up all the water particles on the land surface. So here's a water particle and another water particle, and these two are joined together by a hydrogen bond, represented by the H. When the water particles heat up, they gain more kinetic energy, and this makes them vibrate more. The vibrating breaks the hydrogen bonds holding them together, and they become free. They bounce off each other with a lot of energy, and so they become a gas. This can therefore be described as water loss from the surface of the land, because the water is technically no longer on the surface of the land. It's floating about in its gaseous form of water vapour in the surrounding air. Now let's look at the transpiration part. Those of you who study biology will know that, in its simplest form, transpiration is basically just water loss from plants. So, very simply, the plant takes up water from the soil through its roots, and this water gets pulled up the plant to be used in lots of different processes inside the plant. Later, the water evaporates from the leaves of the plant, or in this case it's a cactus, so stem, in the form of water vapour, which is a gas. So you can see that this is another form of water loss from the surface of the land, because the water is now gas, water vapour, and it's in the air, not on the land. So finally, evapotranspiration is just both of these processes put together. It's the total amount of water lost through evaporation plus the total amount of water lost through transpiration added together, and that number is your evapotranspiration. Thank you for watching, and I really hope this helped you.
Hello and welcome to Engineer Hash Civil Engineer. In this video I'm going to talk about core watering, core depth and core period. Core watering is the first watering done after crops have grown a few centimeters high. Such watering is known as core watering. First of all, you plow the field, you sow the crop and you water it. And then the crop starts to grow. After a growth of few centimeters high, you again need to water. Such watering is known as core watering, and this few centimeters can be around 3 or 4 centimeters. Then the depth of water applied during core watering is known as core depth. And the period within the base period which core watering is done, such period is known as core period. I think you know about base period. Base period is nothing but is the period between the first watering done to the crop and the last watering done to the crop. Such period is known as base period. And basically, the importance of this core watering is nothing but during the initial stages, water requirement of a crop is very high, and this water requirement gradually goes on increasing when the crop reaches maturity. So the irrigation channels should be designed basing on the discharge required for core water. That is the importance, or that is the major principle behind core water. So in this video, if you understand core watering, core period and core depth, please hit like button. You can subscribe my channel, Engineer Hash, for more civil related videos. You can send me feedback at this email ID. You can comment and you can share this video. Thank you.
you